Hello, my name is Alex, and in this episode, with our physical PincherX 100 Trossen Robotics robot, we'll be doing smoke test workflow for this arm that we have on hand, and to be able to verify this in ROS2 RViz2. So the smoke test will include several steps. One of them will be publishing and launching ROS2 node for Robot State Publisher. This is to verify that URDF loads properly and all the link-to-link transforms are being published properly for the robot. Joint State Publisher GUI ROS node will be also launched and executed to manually articulate each joint so we can confirm the kinematics looking good. And the RViz2 to visually inspect the model moving in 3D, check frames, ensure nothing is misrepresented. The PincherX 100 robot from Trossen Robotics has 4 degrees of freedom, and you can see the web page that lists all the joints, including these joints. Also, Trossen Robotics Interbodics ROS manipulators GitHub comes with the URDF X ACRA definition, description of the robot. And the only caveat is that the Interbodics X series repo is ROS1 package, and it's not native ROS2 package. So for that reason, ROS2 won't know about the package called Interbodics XS ARM descriptions, and we're gonna use a different GitHub with the flattened representation of the robot description. And in this GitHub, as you can see, there's an X ACRA modular representation of PX100, URDF X ACRA, as well as the associated meshes. So this is the GitHub that will help us to get started quicker. This is dedicated to a PX100 robot description. It has one robot URDF, and also it links to different types of meshes for components of the robot. And we're gonna basically, instead of installing this PX100 description as a package, for simplicity, we're gonna substitute this with the file reference. But this will help us to get basically going with the ROS2 installation that we have here and RViz that comes with ROS2. There are several terminal windows that will be open, and by sourcing the ROS workspace, first of all, again, this is the substitution of package references to different meshes into file references for different meshes. For simplicity, we call it PX100 underscore processed URDF. And then once this is done, we'll be able to review ROS2 nodes, ROS2 topics, and move on to 3 essential steps for doing the smoke test workflow for our PX100 Trossen Robotics robot arm. So on this step, in another terminal, also by sourcing the ROS workspace, we're looking at the nodes list, and notably you can see there's a robot state publisher, there's a joint state publisher nodes which have been launched, and we'll review them separately. And the third node is obviously RViz for the visualization. The next step for us will be to review the ROS2 topics list, and this will help us to understand how all of the different nodes of ROS2 communicate with each other to make this visualization and this kind of smoke test a reality. So the robot state publisher subscribes to joint states topic and publishes onto TF topic, joint state publisher GUI publishes onto joint states topic, and then RViz subscribes to TF topic, takes into account URDF that we supplied, and then renders the visualization for the robot itself. The purpose of this exercise is to validate the robot descriptions and transforms and everything else, including joint mappings, before moving to more sophisticated things like controllers, sensors, and different autonomous behaviors. So in here, for the list of topics, we can see notably there's a joint states, there's a robot description, and the TF. So now, this is the first step of launching the first ROS2 node from the package Robot State Publisher, executable Robot State Publisher. This launches the node that subscribes to joint states and publishes onto TF. The second node we launch is for the joint state publisher GUI. Package is joint state publisher GUI, and executable is joint state publisher GUI. This brings up the joint state publisher user interface. Again, this will be the changes here will be published onto joint states topic, and the RViz will be picking up those changes. So here we added the fixed frame we set up as a world, we added robot model, and we added TF optionally. And as we doing modifications of different joint positions, you will see you can subscribe to what's being published onto different topics, notably joint state topics and the TF topics. And you can see how all of those values will be changing in real time. So now we're doing different types of manipulations just to like randomizing positions of different joints. And then now waist, shoulder, elbow, wrist, and gripper changes in those joint positions to understand that our robot functions properly and as expected. Once this is done, we completed our smoke test workflow in RViz2 with ROS2, and we can switch to the next step, which will be bringing this URDF robot description into a simulation tool such as IsaacSim 4.5.0, and then visualizing this robot in IsaacSim and taking this forward through our sim to real pipeline. Thank you.